One of the most influential and advanced physicists of our time, Michio Kaku, has shared his perspective on a groundbreaking discovery. Kaku, renowned for his exceptional contributions to physics, recently confirmed that the James Webb Space Telescope has unveiled 6 enormous galaxies, which many scientists had previously thought were impossible to exist. These findings could potentially open new dimensions in our understanding of the universe, making them both exciting and crucial to follow. Kaku is an exceptional figure in the scientific community, a physicist with both American and Japanese roots and an expert in classical experimental physics and quantum mechanics. Unlike some more conservative scientists, Kaku is not part of that group and has embraced the incredible results of the James Webb Space Telescope mission. It's thrilling that this esteemed scientist has chosen to break his silence and publicly share what can no longer be ignored. The enthusiasm, even a touch of amusement, is evident in his remarks regarding the discovery made by the telescope. He expressed that this has become a key highlight that piques his curiosity. Join us as we delve into the implications of Michio Kaku's reflections on the discovery of these 6 vast galaxies. Kaku is a scientist who has consistently been open to considering new theories throughout his career. He acknowledges that the equations of relativity by Einstein and Newton's laws are insufficient for capturing the full complexity of the cosmos. Kaku recognizes that the James Webb Space Telescope's discoveries have the potential to greatly enrich the scientific field. Even though many of his peers have been unable to embrace this view, this has sparked concern and anxiety among proponents of the Big Bang Theory and some supporters of quantum mechanics. However, this only amuses Michio Kaku. The JWST has brought to light the existence of 6 massive galaxies dating back to the universe's earliest periods. These galaxies contain more stars than the Milky Way, despite having formed only 200 to 700 million years after the Big Bang. The astronomers who made this discovery have aptly named these remarkable galaxies universe breakers, since confirming their existence would completely alter our understanding of the universe. Something here doesn't align with what we thought we knew. The Big Bang Theory tells us that the cosmos was in a chaotic state right after the initial explosion. It took hundreds of thousands of years for solid objects to form and additional millions of years for them to accumulate sufficient density and begin emitting light. The formation of complex structures like galaxies was assumed to happen much later. Yet, some of the newly discovered galaxies are even larger than the Milky Way, and their extreme luminosity suggests they were probably forming new stars at a rate far faster than our own galaxy, which forms stars more sporadically. Researchers are still uncertain about when the first galaxies emerged. So far, the only certainty is that initially there may have been only isolated stars or small groups of stars, which later combined to form larger accumulations, ultimately resulting in the development of dwarf galaxies. These small galaxies collided with one another, gradually growing larger. According to past theories, large organized galaxies couldn't have existed at such an early stage, raising the question, is the universe much older than we believed, or did complex galactic structures form earlier than expected? This scenario is difficult for conservative science to accept, which still faces challenges in reconciling this model. Some areas of physics are resistant to this discovery, questioning the accuracy of age calculations. Kaku is aware of these challenges and commented that many outdated and incorrect theories persist due to the prestige of certain scientists. These theories were only disproven when critical experiments revealed their flaws. As Kaku puts it, the core of scientific progress, particularly in physics, relies on experimentalists who ensure theorists remain accountable. In reality, we know very little about the true origins of the universe. The Big Bang Theory, first proposed in 1927, was based on observations showing that the universe was expanding. These observations led to the idea that the universe began from a singular point and has been expanding ever since. At that time, it was difficult for people, including scientists, to conceptualize a universe that had a beginning and an end. The notion of an infinite, eternal universe was beyond their grasp. Even today, scientists continue to grapple with fully understanding this concept. However, it's crucial to entertain these possibilities. Once more, these new findings clash with the foundation that researchers have relied on for decades based on the Big Bang theory. Yet science has repeatedly demonstrated that rethinking established ideas and being open to new concepts is a vital aspect of scientific progress. The validation of theories through observation is an ongoing process. When Einstein was a child, it was believed that stars and planets were fixed in place in the universe, occupying definite positions. However, we now understand that everything in the cosmos is in motion. Planets orbit stars, stars move within galaxies at hundreds of kilometers per second, and galaxies themselves move rapidly through space, their ultimate fate still unpredictable. Today, scientists are coming to terms with erasing uncomfortable truths, realizing that theories are merely hypotheses, not immutable facts, until they are rigorously tested and substantiated by precise observations. The Big Bang theory emerged from the realization that galaxies are moving away from one another with a speed proportional to their distance from Earth. This observation, known as Hubble's law, suggested that the universe was expanding. Additional evidence from elements like cosmic background radiation and the redshift of light from distant galaxies reinforce this theory. However, it's important to remember that in the past, people who believed the Earth was flat and that the sun revolved around us also had evidence supporting their views, until new observations or technological advances led to a more accurate understanding. We find ourselves in a similar situation today. Scientists expected the new James Webb Space Telescope to confirm the assumptions of the Big Bang theory, but instead, it revealed 6 galaxies that defied expectations. This reminds us that science is ever evolving, and scientists must remain open to new discoveries, reevaluating existing theories when new evidence emerges. Researchers rely on redshift as a method to measure various cosmic quantities. Redshift, also known as the Doppler effect, refers to the change in the color of light as the light source moves relative to the observer. Imagine standing still and hearing the sound of a car approaching you. As the car gets closer, the sound becomes louder. However, when the car moves away, the sound changes. Similarly, when a light source like a star moves relative to us, the light shifts toward the blue end of the spectrum as it approaches and toward the red end as it moves away. This phenomenon is known as redshift. Physicists use redshift values to calculate velocities and distances in cosmic measurements. However, it's crucial to acknowledge that even small errors in these measurements can have significant consequences. The measurement techniques that have been used so far are now under review, and it will be interesting to see what conclusions researchers draw from the new data. As for the latest revelations about our universe, we must consider whether they are truly based on redshift errors or if some scientists are simply refusing to accept the facts. This is a question that demands thorough analysis and a careful re-examination of the data and methodologies used in the research. Thank you for watching this video. As always, we encourage you to post your thoughts or questions in the comment section. If you like the video, don't forget to hit the like button, share it to reach a wider audience, and subscribe to the channel so you don't miss future content. Thanks again for watching, and we'll see you in the next one. The recent advancements and findings in space research remind us that the scientific community must remain flexible and adaptive to change. New discoveries can often challenge deeply held beliefs and established theories. The James Webb Space Telescope's remarkable revelation concerning the 6 massive galaxies demonstrates this ongoing process of reevaluation. As we continue to study the cosmos, we should keep in mind that the universe might be far more intricate and mysterious than we previously understood. The galaxies uncovered by the telescope, which exist much earlier than traditional models would suggest, may require an overhaul of many of the concepts we have long taken for granted. This development is not merely an anomaly, but rather a pivotal moment in the history of scientific progress. Scientists, including Kaku, emphasize that our understanding of the universe is incomplete, and each new discovery only adds layers to the ever-evolving mystery of the cosmos. The evolving narrative of cosmic exploration. The resistance that some in the scientific community express towards these new findings is not uncommon in the history of science. Paradigm shifts often face skepticism from those invested in the old models. However, as Kaku points out, history is filled with examples where once accepted theories were eventually replaced or modified after groundbreaking experiments and observations. It is this openness to change and discovery that has propelled human knowledge forward and allowed us to make sense of the universe in ever more profound ways. The significance of these new findings is not just in their challenge to existing theories, but also in their potential to unlock new avenues of research. For instance, understanding how these massive galaxies formed so early in the universe could lead to a rethinking of galaxy formation processes. It may even prompt revisions to models of cosmic evolution, especially concerning the rate at which stars form and galaxies evolve. As more data becomes available, we may be on the verge of a new era in cosmology, one that challenges the very foundations of what we thought we knew about the universe's history. Kaku's perspective on the matter is crucial because of his willingness to embrace new evidence and ideas, regardless of how disruptive they might be. His recognition of the importance of the James Webb Space Telescope's discoveries reflects a broader shift in scientific attitudes towards more openness and flexibility. In the face of new information, the scientific community has long relied on empirical data and rigorous testing to form conclusions, but sometimes, as we see now, the data can lead us to unexpected places that force us to rethink even the most fundamental assumptions. In the end, the work of scientists like Kaku is a reminder that the pursuit of knowledge is ongoing. We are constantly on the lookout for new data that might reshape our understanding of the universe. Whether it is through new telescopes, more advanced instruments, or novel theoretical frameworks, the journey to uncover the secrets of the cosmos is far from over. These recent findings will likely be just the beginning of an exciting new chapter in the field of astrophysics. As we move forward in this journey of discovery, we must remember that science is a process, one that is driven by curiosity, skepticism, and above all, a relentless pursuit of truth. The revelations made by the James Webb Space Telescope are not just the work of a few astronomers, but part of a larger collective effort to unlock the mysteries of the universe. Every new piece of data adds to the puzzle, and each discovery offers a new lens through which we can view the cosmos. This exciting time in the field of space exploration encourages us all to remain engaged with the wonders of the universe. The questions raised by Kaku and his peers remind us that there is so much more to learn and discover. Perhaps, as new findings emerge, we will see even more shifts in our understanding of space, time, and the very nature of reality itself. The journey is only just beginning, and who knows where these new insights might take us in the future. Thank you again for following along in this exploration of the latest discoveries in space science. We encourage you to keep asking questions, keep searching for answers, and above all, keep exploring. Our understanding of the universe is still unfolding, and with every new discovery, we move a step closer to understanding the incredible complexity of the cosmos. The implications of these findings are profound, not just for our understanding of the universe, but also for the broader philosophical questions that have long occupied scientists and thinkers. For centuries, humanity has wondered about the origins of the cosmos and its true nature. The Big Bang Theory has been a central tenet in explaining how the universe came into existence, but these new discoveries challenge that view. The galaxies discovered by the James Webb Space Telescope suggest that our universe could be far more complex and older than we previously thought. This shift forces us to reconsider everything from the formation of galaxies to the very structure of the cosmos itself. As Michio Kaku and others in the scientific community have pointed out, it's crucial to approach these new findings with an open mind. Science is a process of continuous questioning, testing, and refining ideas. What we once accepted as fact may no longer hold true as we uncover new evidence. The skepticism faced by these recent revelations is part of the natural process of scientific discovery, and while it can be uncomfortable, it's an essential part of pushing the boundaries of knowledge. The excitement, however, is palpable among those who are eager to explore these anomalies and their implications for our understanding of the universe's early stages. It's worth noting that the discovery of galaxies that formed so early in the universe presents significant challenges to existing models of cosmic evolution. As we continue to grapple with these groundbreaking discoveries, the implications extend far beyond just galaxy formation. The detection of these 6 massive galaxies, far more ancient than previously believed possible, could drastically alter the way we understand the very fabric of the universe.